Hello kids, welcome to another math video. This is Eureka Math Grade 5, Module 1, Lesson 16, homework, and it is word problem day. So hooray, this is always a lot of fun. I know kids don't say fun, they always say it's terrible, we hate word problems, but we're going to try to show you ways to break them down so that they are not so terrible. So we're going to solve these using tape diagrams. It's always better if you can look at a problem and see the parts that make the whole. And that's really what tape diagrams are all about. So let's get started. A gardener installed 42 6/10 meters of fencing in a week. He installed 13 4500 meters on Monday and 9 5/10 meters on Tuesday. He installed the rest of the fence in equal lengths on Wednesday through Friday. How many meters of fencing did he install on each of the last 3 days? So one of the things that I am totally terrible at is reading through the whole problem. So it's really hard for me to actually read through the entire thing. I don't want you to be like me, but be good at reading through first, because I like to take things apart and say, oh, well, look at this, look at this. And so we can go back and do that before we make our tape diagram. So let's go together and make a tape diagram now that we've read the whole thing. So it's the 42 6/10 meters in a week, then we're going to break it all up. Now we talk about these 5 days, so make 5 different boxes, okay? And just, we're not going to have enough room for numbers, so Monday, Tuesday, Wednesday, Thursday, Friday. Just label them like that. Okay, now we do know the total is 42.6 meters, and I always like to make these little curvy things, bracket, whatever you want to call it, to show like different parts. And we do know that there are some amounts that are given. 13.45 for Monday, 13.45 meters on Monday, and 9.5 on Tuesday. The rest of the amount is going to be divided equally. So these word problems, man, they're always hard, and there are multiple steps. So what are we going to do first? Well, we need to know the total amount that was already installed, so we can take that away from the total amount that's installed in the 5 days. So step 1 for me would be to add the 2 days of already installed fencing. Okay, line up your decimals, add everything up. This comes down, 5 and 4 is 9, decimal down, 9, 10, 11, 12, carry the 1 and 2. So you should end up with 22 95 meters that were already installed. Now what? Well, now I need to find out the amount for these 3 so that I can divide it by 3. So take your 42 6/10, and then we're going to take away what's already been installed. Line up your decimals. Okay, so this is like step 1. Actually, step 1 is make the tape diagram. Step 2, we're going to subtract. Now, don't be alarmed that there's nothing here. Just place a decimal there, because remember, you can take away from decimals, but you have to go here. You cannot just say 5 minus 0. No, that is not what you're doing. You are not taking anything away from here. You are taking away from here. Go next door. Take 1, give 10, so that you have 10 on top. 10 minus 5 is 5. Some kids will say, well, I got 5 anyway. And I'm like, yeah, but you're not going to get the right answer here, because you should no longer have 6/10. You should have 5/10. So there. Let's fix it now. 5 minus 9 can't do. Fix it here. Take 1, give 10. 15 minus 9, 6, decimal down. 1 can't take away 2. That's okay. Take 1, give 10. 11 minus 2 is 9, and 3 minus 2 is 1. Now we have our 19 65 meters that is represented here. And so this amount has to be divided evenly by the 3 days that are left. So we're going to set up our division with a standard algorithm now that you are getting better at it. Don't have to be a pro, we're getting better. 19.65. Decimal up, don't forget, just start with that. Now when I don't have enough to share into the 3 groups, I'm going to regroup that into the ones place. Now I have 19 ones divided into these 3 groups. So 19 divided by 3, we want to use as many as we can, and that would be 6 in each group. 6 times 3, 18, with 1 left. Regroup that into the tenths place so that we have 16 tenths, and divide that by those 3 groups. Put 5 in each group, using a total of 15 tenths. Subtract and get 1, and then we bring down our last hundredths place digit to regroup all those together. Now I have 15 hundredths divided by 3, which we know we're going to get that even 5 because we already got 15 there. So multiply, subtract, and we're done. We have nothing left over, so what does this mean? This is meters of fencing. So we're going to rewrite it because our word problems always require words in the answer. And so the question goes, how many meters of fencing did he install in each of the last days? We're going to talk about the gardener. He installed 6.55 meters of fencing on each of the last 3 days. Okay? So write everything out, take the time, make it neat, keep your place value positions lined up, and you're done. So yes, there's a lot. This is step 3. This is step 4. Yes, there's a lot. So I'm sorry, I didn't make up these programs. But you know what? This is kind of like life, so get used to it. Don't be afraid. Just practice. Okay, next one. It's a double whammy, 2A and B. So let's read the whole thing through. Even I need to practice. Jenny charges $9.15 an hour to babysit toddlers and $7.45 an hour to babysit school-aged children. Why doesn't she just round up? It'd be so much easier. Anyway, if Jenny babysat toddlers for 9 hours, ooh, look at me stopping, and school-aged children for 6 hours, how much money did she earn in all? So for part A, don't worry about part B yet. For part A, we're going to take the 9 hours for the toddlers and the $7.45 for the school-age children, and we're going to try to get some totals for this money that she earned in all. Okay, so take the hourly rate, and if you wanted to use the area model, I would say go ahead and use the area model. I'm not going to do it because I love the standard algorithm, so we're going to practice that a lot. And the toddlers is going to be 9 hours. So we take these and we multiply across every place value position. So 9 times 5 is 45, carry the 4. 9 times 1 is 9, 10, 11, 12, 13, carry the 1, 81, 82. Now it's hundredths times ones for hundredths. $82.35 for toddlers. But that's not the end. That's only part 1. Now for school-age children, she babysat for 6 hours. $7.45 an hour times the 6 hours she watched those kids. Again, take the ones times the, what you would say, we've got hundredths, all the way across, digit by digit. 6 times 5 is 30, carry the tens place over. 6 times 4 is 24, 25, 26, 27, carry the 2, 42, 43, 44. Know your facts, kids. Know your facts. Now we've got the 2 different amounts and we want to know the total. So guess what? Step 3, combine those. And keep your work neat and line up your place value positions carefully. 5 plus 0, 7 plus 3 is 10. Carry the 1, decimal down. 4 and 2 is 6, plus 1 is 7, and 8 and 4 is 12. $127.05. And, and the tape diagram. Okay, so if we have the 9 hours, let's see, 82.35, that's going to be 9 hours. 1, 2, 3, 4, 5, 6, 7, 8, 9. And that's going to be 9:15. Squeeze that down here per hour question mark was, and that's where we get that. And then we've got our 6 hours at 7:45. 1, 2, 3, 4, 5, 6. 7:45. Total amount there for toddler, for school age. And then you can combine those two together to get your total. Okay, next one. Jenny wants to earn $1,300 by the end of summer. Let's start out with the tape diagram. Oops, I need to finish reading. How much more will she need to earn to meet her goal? $1,300. She already earned $127.05, but that's a big number, so I'm going to make a small piece here. If you can't fit it, don't try. Just put it below. Already. Okay, so she already earned, and this is what we're looking for here. Still needs. Okay, so we've got our part that we have, the part that we need, and the whole. Again, the crazy bracket. So what do you want to do? You want to find the difference. 1,300 minus, now watch me put the decimal there, and then line up your place value positions. 127.05. We're taking that away. Put a couple of zeros. That way you can subtract from something because you have to have that there. Okay, no problem with zeros on the top. Remember the trick that I showed you. So nobody's home, nobody's home, nobody's home. Take 1. Drop out those 9s. They're parachuting down all the way until we deposit the 10 at the end. Okay, that's the shortcut. Remember, it's always 9s in the middle until you get to the 10 at the end if you're going over zeros. Otherwise, it's take 1, give 10, take 1, give 10, take 1, give 10 every time. Anyway, got the 10 at the end. Here we are, 10 minus 5 for 5. 9 minus 0, 9, decimal down, subtract and get 2, 9, 8, 7, 2 minus 1 is 1, and 1, you should end up with $1,172.95. And so Jenny still needs to earn $1,172.95. There you go. See, I even just stuck that right in there so I didn't have to rewrite it. Number 3. Here we go. Doing good. You're doing great. Doesn't it feel nice to kind of understand a little bit? All right, a table and 8 chairs weighs 235 and 68 hundredths pounds together. Kids have a hard time reading that, so did I, but it's 235 and 68. Say the place value position hundredths and then say the label together. If the table weighs 157 and 84 hundredths pounds, what is the weight of 1 chair in pounds? Okay? Always check your labels too, because sometimes they'll say, oh, this is grams and this is pounds, and so, oh, that really messes everything up. Or they might do pounds, and then another one would be ounces, since the metrics and the standard measure don't really go together. Anyway, let's take the total in our tape diagram, which they love to see you practice, and it's going to be at 235.68 pounds for the table and chairs. Okay, now if the table is 157, so let's just say the table is a little bit more than half, and we give it our value, 157.84, then what is the weight of 1 chair? Well, how many chairs do we have? We have 8. So I'm going to split my chairs into 8 sections because the question is asking about one of them. So that's what we're searching for in our solution. So what are we going to start with? Well, we have to take away what we know from the other thing we know, which is the total minus the table. Sorry, I got to fold this thing down. It's bothering me. 235.68 is the total minus the weight of the table, so that we can see what the chairs weigh all together. 8 minus 4 is 4. 6 minus 8, can't do it, but don't worry. Take 1, give 10. 16 minus 8, 8. What do we do next? 4 minus 7, can't do it. Take 1, give 10. 14 minus 7, you can do, and that's a 7. 2 minus 5, can't do it. Take 1, give 10. 12 minus 5, you can do it. And then 1 minus 1 is 0, so we don't have to put that. Now, we've got our 7784, and that is for the chairs all together. Pounds. 77.84, 77 and 84 hundredths pounds. These are all pounds. Pounds, pounds, pounds. So what do we do now? Well, we've got 8 of them, and we need to only find 1. So we're going to share evenly. That's division. 77.84. Decimal up and start over here. When there isn't enough here, we regroup. This is a really big number. You have to know your facts. 8 times 9 is 72. Subtract all these and get 5 left over, which is less than 8, so I can move on and regroup that 5 with the 8/10. Now I have 58 divided by 8. Know your facts. Again, if you know the even ones, you could even do like 8 times 8 is 64. And so it has to be less than that. And how much less than that is it? It's super close. We're going to try that 7. And go from 64 and subtract 8 if you need to. Like, find the facts that you do know and use them to help you get the ones that you don't know. Anyway, 7 times 8 is 56. And you subtract and get 2. And we're going to regroup that with the 4 in the hundredths place. And guess what? 24 divided by 8, should know, is exactly 3, which leaves us with nothing left over, and 9 and 73 hundredths pounds per chair. Yay. So we found another one. Okay, so I hope that makes sense. So those tape diagrams, the purpose of it is to show the different parts that make up the whole. And then you can see, oh, it was time for the lights to go out. And then you can see what you have to solve for. So these little pictures are great. Let's do the last one. Mrs. Cleaver. If you don't know who Mrs. Cleaver is, then you're just not old enough, I guess. Okay. Mrs. Cleaver mixes 1 24 hundredths liters of red paint. Ooh, this is a hard one. I remember this. With 3 times as much blue paint to make purple paint. Don't get lost in the purple paint like I did my first year. She pours the paint equally into 5 containers. How much blue paint is in each container? They don't care about the red paint. We just have to start with that so that we can make our tape diagram. Give your answer in liters. Okay, so here's what if I could tell you how many times I did this wrong, it's embarrassing. Okay, take a look at the red paint. Red paint is 1.24 liters. Okay, 3 times as much blue paint. So I like to do these sometimes that show all the little pieces, and this is where it actually kind of got me confused in the beginning, because I was like, oh, let's make all the purple paint. I just wanted to make purple paint so badly. But we don't really have to do that. We just need to know about the blue paint. Okay, so she pours the paint equally into 5 containers, but that's kind of misleading because they only want to know about the blue paint that's in each container. So I really just need to know this amount. So what is that amount? Well, 1.24 3 times. Now some students will add those 3 together, and that's totally fine. Okay, that's up to you, but I'm going to multiply because I like the standard algorithm. 4 times 3 is 12, carry the 1. 3 times 2 is 6, plus 1 is 7. 3 times 1 is 3. It's hundredths times ones for hundredths. This is the total. Hopefully you got that when you were adding. So 3.72 liters of blue paint. Keep the eye on the blue. Now we're going to share this into the 5 containers, not losing sight of our purpose, which is just finding the blue. And let's start dividing. 3 cannot be divided into 5 groups, so we put a 0 there, and regroup it into the 37 or into the 7/10, which makes 37/10. Now 37 divided by 5, you should know, is 7. 7 times 5 is 35. Subtract and get 2. Bring down, this is less, so we go on. Bring down, now I have 22 hundredths that are divided by 5. I could fit 4 into each one using 20. 2 are left over. And don't forget our strategy from lesson, whatever it was, 13. Annex a 0, bring it down so we can get an exact answer. Take it out one more position because it's just a good skill. Look, we're right so close. 20 divided by 5 is 4 exactly. Again, we knew that because we already solved for it. Multiply, subtract, get the 0. Yay, we're happy. And so the final, how much blue paint is in each container? 0.744 liters. And, oh, I forgot to say, subscribe and come back. Click subscribe and come back. So, Mrs. Cleaver, write your very nice answer. Poured, has 0.744 liters of blue paint in each container. Yay! Don't you feel like a success? You are. You're fabulous. We'll see you on the next one. Bye for now.